Dawn in Minnesota, rich in natural beauty and natural resources. Here among the countryside's brilliant colors, a process begins that touches the lives of all of us, making steel. There is nothing as exciting, beautiful, or important in the industrial world than the making of steel. It's a business of unparalleled size, where processes are measured in terms of millions of tons, temperatures in thousands of degrees, investments in billions of dollars, and quality in 10,000ths of an inch. At LTV Steel, the complex process of steelmaking involves massive machinery, some over 20 stories tall, controlled by the most advanced computer equipment systems, and managed, operated, and maintained by highly trained men and women. While there are many types of steel, engineered to each customer's specific needs, there are 5 basic steps to steel making. Mining the raw materials, reducing them to molten iron in the blast furnace, refining the iron in a steelmaking furnace, casting the molten steel into slabs, and rolling and finishing the slabs into high-grade flat-rolled 10-mil and tubular steel products. The people at LTV Steel are committed to achieving excellence in product quality and total customer satisfaction through continuous improvement in everything we do. Today, LTV Steel proves that commitment by offering the only 100% quality guarantee in the steel industry. Headquartered in Cleveland, Ohio, LTV Steel has fully integrated steel mills in Cleveland and at Indiana Harbor near Chicago, coke plants in Cleveland and Warren, Ohio, Chicago and Pittsburgh, a modern finishing and galvanizing mill in Hennepin, Illinois, electro-galvanizing facilities in Cleveland and Columbus, Ohio, tin mills at Indiana Harbor and Aliquippa, Pennsylvania, near Pittsburgh, pipe and tubing plants in Cleveland, Elyria, and Youngstown, Ohio, Cedar Springs, Georgia, Ferndale, Michigan, and Counce, Tennessee. Major markets for LTV Steel's flat-rolled products are automotive, appliance, electrical equipment, steel service center, construction and contractor products, agriculture, converter, and other domestic and commercial equipment. The tubular and pipe plants supply products to diverse markets such as automotive, energy, construction, electrical, agriculture, steel service center, and various other markets. LTV Steel's tin mill products are primarily used for food cans, including vegetables, juices, fruits, pet foods, soups, and others, general packaging for aerosols and paints, beverage cans for soft drinks, closures, including bottle caps and jar lids, and oil filters and air filters for the automotive market. In the next few minutes, we'll give you an inside look at these modern facilities and the exceptional people who produce our premier quality steel. We invite you to see excellence in the making. The first step in the steelmaking process is preparing the primary raw materials, which are taconite pellets, coke, and limestone. LTV Steel's iron ore comes from taconite, mined at the LTV Steel Mining Company in northern Minnesota. State-of-the-art testing equipment ensures that the ore meets the exact chemical quality parameters required. Because of its extreme hardness, taconite must be blasted from the mine floor. It's loaded into 250-ton haulage trucks and transferred to a processing plant via rail cars. The iron content of this crude taconite is only about 30%. To produce pellets of higher iron content, the ore is crushed in a machine that resembles a giant mortar and pestle. When material is ground to a face powder consistency, so the iron-bearing particles can be separated by powerful magnets. The concentrate, now 67% iron, is rolled into balls or pellets and hardened in furnaces. LTV Steel Mining produces over 7 million tons of taconite pellets each year. The pellets, each about the size of a marble, are then loaded onto ore boats, or lakers. These vessels can be as long as 3 football fields and carry as much as 60,000 tons of pellets. Their destinations are LTV Steel's Indiana Harbor blast furnaces or the Lorraine Pellet Terminal, from which the ore pellets are shuttled to the Cleveland Works blast furnaces. Coke is another essential raw material used in iron making. Each year, millions of tons of coal are made into coke, which serves as the basic fuel of the blast furnace. The coal provides a key element, carbon, which is necessary in both iron and steel. Coke is made by heating coal in long, narrow, airtight ovens for 16 to 18 hours to remove tar, oil, sulfur, and other materials, leaving pure carbon. The materials or byproducts removed from the coal are recovered and sold to other industries. Limestone, the third raw material essential to iron making, is used to purify the molten iron by trapping such impurities as sulfur, which can be separated from the iron. Iron producing is the second step in the overall steel producing process. The raw materials, iron ore pellets, coke, and limestone, are loaded into the top of the blast furnace in a carefully planned sequence. Quality and efficiency are enhanced by an intricate network of microprocessors and computers that monitor and control all critical phases of the operation. Inside the furnace, a continuous blast of superheated air causes the coke to burn with great intensity. The high temperature, nearly 3,500 degrees Fahrenheit, releases the iron from the ore. Byproduct gas is used to make steam and electric power for use in the LTV steel plants. Periodically, the blast furnace is tapped, and as much as 500 tons of molten iron is drawn off and sent to the steelmaking furnaces. The next step is actual steelmaking, a process which purifies iron to make steel. The first type of furnace we'll look at is the BOF, the basic oxygen furnace, a refractory-lined vessel that can hold up to 300 tons. Nearly 100 tons of steel scrap is charged into the vessel in a predetermined metallurgical quantity calculated by computer. A portion of this recycled scrap is used steel cans. Annually, LTV Steel consumes approximately 500 million used steel food and beverage cans in the steelmaking process. Next, about 200 tons of molten iron are poured into the furnace. The BOF vessel is rotated to an upright position, and a water-cooled lance is lowered into it. Pure oxygen is blown through the lance at supersonic speed into the molten iron. A sublance is used to permit the operators to measure the temperature and chemistry of the molten metal, approximately 85% into the blow. Corrections can be made at this time to prevent reblows. The use of the sublance results in better alloy recovery, improved cleanliness, and reduced refractory costs. The chemical reaction between the carbon in the iron and the oxygen refines the iron and melted scrap to obtain the steel chemistry desired. In the bottom stirring procedure, either argon or nitrogen gas is injected through tweers in the bottom of the BOF vessel. The stirring action of the metal by the gas improves the mixing between the slag and metal interface, resulting in better uniformity of the bath. The mixing leads to better yields and improved cleanliness. The processing takes about 25 minutes. LTV Steel uses advanced computer technology to calculate the chemistry and composition of the charge, and to analyze and monitor the chemistry during the refining cycle. A hood and duct system carries emissions to a pollution control system for removal of dust and fumes. Steel scrap is the only iron-containing material used in our second steelmaking method, the electric arc furnace. The steel industry is the largest recycler in America, recycling twice as much material as all other industries combined. In addition to making good business sense, recycling helps our company and industry be good environmental citizens. Here at the Cleveland Works, electric furnaces are charged with nearly 200 tons of scrap for each heat. A powerful electric current, up to 60,000 amps, arcs between large electrodes and the scrap. This violent action creates intense heat and melts the charge. Purifying agents and alloys are added during the processing. Data on each heat or batch of steel is stored in a base computer system and is fed to other systems, which are available to production units, technical service, engineering, and sales personnel within minutes after a heat is poured. One of these systems, known as Model 204, is a key part of LTV Steel's integrated process control system, our method of achieving total quality control. Tightening specifications for high-quality steels has led to the addition of a secondary step in the steelmaking process. LTV Steel's Ladle metallurgy facilities reflect the company's commitment to improving quality, with the capability to make final adjustments to the steel's temperature and chemistry before going directly to the caster or to an additional process at the vacuum degasser. The vacuum degasser produces ultra-low carbon steels by treating the steel in a vacuum to achieve carbon and oxygen levels below those attained in the BOF. Steel is made to specifications of under 50 parts per million of carbon. LTV Steel is the leading producer of ultra-low carbon steels in the United States. These steels can be formed into more complex shapes than other grades of steel and are used in the electrical equipment and automotive industries. The fourth step is producing a steel slab that can be rolled and shaped. After leaving the ladle metallurgy facility or the vacuum degasser, the steel moves on to a continuous caster. The ladle of molten steel is placed on a turret and rotated into position over the casting machine. The steel is drained from the ladle through a ceramic shroud into a bathtub-shaped vessel called a tundish, which allows additional impurities to be removed. From there, it flows through a shroud into the caster's water-cooled mold. These shrouds exclude air from the steel during pouring to keep impurities from forming. The cleaner steels result in fewer defects at customers' plants. As the molten steel begins to solidify, it moves downward on a curved path through the casting machine and is further cooled by high-pressure water sprays. As the steel emerges from the casting machine, it is straightened into a continuously moving ribbon of steel, 9 to 10 inches thick, which is cut into slabs of specified lengths. Continuous casters make semi-finished products of excellent internal and surface quality. The process converts the molten steel directly into semi-finished shapes with minimum yield loss and no energy expenditures. At the Cleveland Works West Side Direct Roll Complex, the slabbing mill and hot strip mill are in line, permitting us to convert ingots directly into hot bands. Direct rolling requires ingots of the highest quality, tight scheduling, and strict rolling practices to meet the demanding quality of our customers. And elimination of the traditional reheating step presents a major cost savings in energy. A new sophisticated continuous slab caster complex is under development for Cleveland West, combining the benefits of continuous slab casting and direct rolling. In the next steelmaking step, semi-finished shapes blossom into a great variety of finished steel products. LTV Steel converts its slabs into flat-rolled products such as hot and cold-rolled sheet, hot dip and electrogalvanized sheet, tin plate, motor lamination sheet, scalp, which is used to make welded pipe, and hot and cold-rolled coils for various tubing applications. The slab is reheated and rolled through one of LTV Steel's 3 sophisticated, powerful, and energy-efficient hot strip mills. A series of roughing stands roll the steel from a thickness of 9 or 10 inches to about 1.5 inches. The final thickness is established as the strip, now more than 1,000 feet long, passes through the finishing train. Advanced computerized controls guide the entire process, including laminar water sprays to meet the required coiling temperature, until the strip is wound into a coil at the end of the line. The thickness now is just 75 thousandths to 1/2 an inch. All of the contact water used in this or any of the other steel-making processes at LTV Steel is treated at on-site treatment plants and returned to the environment cleaner than it was prior to processing. From here on, a newly made hot-rolled coil may follow one of several different paths through the production system, depending on the end product. The coil may be shipped without further mill processing and used as scalp to make electric weld pipe, or as sheet for automotive wheels and structural components for metal buildings. Most hot-rolled coils are run through an acid bath, a process called pickling. This continuous pickle line removes scale or oxide from the surface of the strip prior to sale or in preparation for further processing. Next, the strip is cold rolled in a powerful, high-speed 5-stand tandem mill. Cold rolling reduces the strip to a thickness to meet the customer-ordered specification. The thickness of the strip ranges from 15 thousandths to 1/8 of an inch. Computerized controls maintain tight thickness tolerances as the strip is reduced at processing speeds as high as 5,000 feet per minute. In order to form the various end-use shapes, the strip must be softened by heat treating, called annealing, to relieve internal stresses, develop proper grain structure, and reduce the hardness imparted by the cold rolling process. One way to heat treat the steel is to stack batches of coils in furnaces with a removable top. This is called batch annealing. The other way is to put the coils through a continuous annealing line like this one at LTV Steel's Indiana Harbor tin mill. At Cleveland Works, a new state-of-the-art continuous annealing line with inline temper rolling is designed to process 75,000 tons of coils per month. The system uses 30% less fuel than the batch anneal process and reduces processing time by at least a week. After annealing, most cold-rolled steel is rolled once again in a temper mill to impart the specified flatness, hardness, and surface texture to the strip. Galvanized steel, which is coated with a thin layer of zinc as protection against corrosion, is made in two ways. One is the hot dip process, in which the strip is drawn through a pot of molten zinc. The number 2 galvanizing line at LTV Steel's Indiana Harbor Works, rated the most productive in the world, is capable of coating 60,000 tons of coils per month. There is a second galvanizing line at Indiana Harbor and another at our Hennepin finishing plant. The alternate process is electrogalvanizing, which uses an electric current to apply pure zinc to the coils. LS Electrogalvanizing Company, the LTV Sumitomo Metal Industries state-of-the-art line in Cleveland, provides zinc-coated sheet with a surface smoothness, uniformity of coating, corrosion resistance, and ease of processing demanded by auto and truck manufacturers. LS2 Electrogalvanizing Company, a second LTV Steel Sumitomo facility located in Columbus, Ohio, produces steels coated with zinc, zinc-nickel alloy, and zinc-nickel alloy with an additional protective organic coating. Tin plate products, which are widely used for food and beverage containers, are also made by the electrolytic process. Tin plate is rolled to thicknesses as light as 58 ten-thousandths of an inch, at speeds exceeding 5,000 feet per minute. After cold rolling, annealing, and temper rolling in one of LTV Steel's tin mills, the strip goes to a continuous plating line, which applies a thin layer of either tin or chromium. Prior to shipping to the customer, the product receives final processing, where it is slit or trimmed, inspected, and packaged. At LTV Steel, we are continuously striving to improve our quality. Our technology and customer technical centers, located in a suburb of Cleveland, provide customers with an experienced staff and advanced laboratory facilities to develop new technology and to test new products. Our integrated process control system for total quality control, which has gained worldwide recognition, is utilized not only in the steelmaking process, but throughout all departments in the company. IPC enables us to effectively control the key input variables that have a critical effect on product quality for both our internal and external customers. Our sales and customer service staffs utilize state-of-the-art information systems, including the electronic exchange of information with customers, carriers, and outside processors, to provide sales support and service which differentiates us from our competition. LTV Steel continues to invest in upgrading our existing facilities, as well as construction of new operations. While LTV Steel strives to be world competitive, we never lose track of two important goals: working safely to prevent injuries and employing state-of-the-art environmental equipment to be good neighbors. All of this, combined with a participative and skilled workforce, makes LTV Steel a leading producer of quality steel, engineered to meet the demands of products that enrich our lives every day. Our people, our suppliers, our facilities, and our equipment are all dedicated to meeting the needs of our customers. At LTV Steel, excellence is in the making. We guarantee it.